Okay, we're back here for the second part of the notes. The next rule, raising an expression to the 0 power. Anything to the 0 is always equal to 1. Anything raised to the 0, you can take the calculator, pick a number. 5,892 raised to the 0 equals 1. 25 to the 0 equals 1. Anything to the 0 is 1. Okay, I'll show you why in a second, but let's look at the examples. Number 9, this whole thing is being raised to the 0. It equals 1. For number 10, 5 squared, that's 25, 5 times 5. 2 to the 4th is 2 times 2 times 2 times 2, which is 16, times 7 to the 0, which is 1. Now, I don't raise all of it to the 0 because it's not parentheses to the 0. It's not like number 9. Okay, so now I just multiply 25 times 16, which is 400, times 1, which is 400. That's it. That's my answer. Negative exponents. Anything raised to a negative exponent, what we do is take the reciprocal. We flip the fraction, basically. A to the negative n becomes 1 over a to the positive n. Okay, again, I'll show you this. Well, let's look at this on the side here. So you know 2 to the 4th, 2 times 2 times 2 times 2 is 16. Every time I raise this, if I go 2 to the 5th, I multiply this by 2, it's 32, and then 64, and then 128, and so on. But if I decrease the exponents, 2 to the 3rd, 2 times 2 times 2 is 8. 2 to the 2nd is 4. 2 to the 1st is 2. Notice the pattern. Every time here, I divide by 2. So if I continue in this pattern, if I divide 2 by 2, I get 1. Now notice the exponents decrease, so 2 to the 0 equals 1. Now let's keep going. 2 to the negative 1 equals half of this. I divide by 2, it's 1/2. 2 to the negative 2 equals 1/4. Now 1/4 is 1 over 2 squared. So you've got a couple things going on here. First of all, anything to the 0 is 1. Here's a demonstration of that. And also with negative exponents, 2 to the negative 1 becomes 1 over 2 to the positive 1. 2 to the negative 2 becomes 1 over 2 to the positive 2. If we kept going, 2 to the negative 3 equals 1 over 2 raised to the positive 3. Okay, so that's a demonstration of both of those rules. So let's do the examples here. Number 11, 2 to the negative 1 is 1 over 2 to the positive 1. In this case, it's 1/2. 5 to the negative 2 is 1 over 5 to the positive 2, and we'll say that's 1 over 25. Now with just regular numbers like this, you could check this on the calculator. 5 to the negative 2 power gives me a decimal. I can go math, enter, enter on fraction, enter, there's your 1/25th right there, okay? X to the negative 4th, that's 1 over x to the positive 4. Now, if you have something in the numerator and the denominator, well, anything in the numerator to a negative power is going to come down. It's like the reciprocal, I flip it. Anything in the denominator raised to a negative exponent will come up to the top. So it'll be y to the 1 on top, x to the 5th on the bottom. We don't need the little 1, y over x to the 5th. That's it. Okay, so what happens now when you move it, the negative exponent also becomes a positive exponent, so don't forget about that. Okay, so let's go to dividing monomials. And the rule for this one, when you divide variables, you subtract the exponents. When you multiply, you add the exponents. When you divide, you subtract the exponents. X to the 7th divided by x to the 4th. Here's example number 15. So what we do is we subtract 7 minus 4. We do the top exponent minus the bottom, and what we get is x to the third. Now, the reason why this works, if I was to expand this, x to the 7th, so there's 7 of these x's multiplying, x to the 4th, there's 4 of them multiplying. Now, when you're dealing with multiplication here as part of a fraction, you can start dividing, you can reduce this. X divided by x is 1. X divided by x is 1, 1, 1. So all of this is 1 times x times x times x. So what's left? X to the third. There's your answer. Now we don't do this, we like to subtract it because that's going to be faster. Okay, so number 16 here. Remember that this is a division problem. So when you have coefficients, regular numbers, you're dividing these. It's 12 divided by 4, which is 3. So it's 3x to the 6 minus 2, and then that's y to the 10 minus 1. Don't forget that exponent is a 1, and we get 3x to the 4th, y to the 9th. Now you don't really need to show this step. You can do the subtraction in your head. For number 17, we'll do x to the 12 minus 15, which is x to the negative 3. And then y to the 8 minus 2 is y to the 6th. Now notice that we get a negative exponent here. We do not leave it as a negative exponent. So what I have to do, right now, imagine that this is a fraction. I put it over 1. Okay, normally you don't show this, but this is what's happening. I'm going to take x to the negative 3, and I'm going to bring it down. So what happens, y to the 6th stays like it is, but x to the negative 3 comes to the denominator and becomes x to the positive 3. And that's how we do that. All right, let's look at 18. Okay, lots of stuff going on here. So take it piece by piece. We can reduce 6 over 24. And what we get there, that's going to reduce to 1/4. 1 over 4. So we've got 1/4. Now I'm going to take my x's. I'm going to subtract the exponents. Now that's negative 2. I subtract whatever the bottom exponent is. So if it's a negative, it's minus negative 3. It's minus a negative. And then for the y variable, I copy the base. I subtract the exponents. 3 minus negative 5. So when I simplify here, minus a minus, remember that that will become positive. So we get 1/4, x to the negative 2 plus 3, which is 1, and then y to the 3 plus 5, which is y to the 8th. Now this is a good answer, but you could also write this. You have a fraction times xy to the 8th. The xy to the 8th goes in the top when you think about it. So you could also write this. X, y to the 8th over 4. That's how you would put it. Okay, so be very careful. Well, either one of these is fine. Okay, I tend to just keep the fraction like it is, or I put the fraction in front. But if you want to put xy to the 8th somewhere, you have to put it in the top. Okay, that goes in the top. So we got a few more examples here. We've got number 19. Lots of stuff going on here. Before you do the division, simplify the top, simplify the bottom. And in this case, we're going to simplify the top. The top, we're going to multiply these two monomials, these two terms. So 2 times 10, 20. X to the 5th times x to the 3rd. When you multiply the variables, you add the exponents. So that's x to the 8th. Y to the 2nd times y to the negative 1. That's going to be add the exponents. 2 plus negative 1 is 1. Over 12, x to the 4th, y to the 9th. Now we can do the division. Okay, so starting with 20 over 12, each of those is divisible by 4. So I'm going to reduce it. That would be 5 over 3. 20 divided by 4 is 5. 12 divided by 4 is 3. So we get 5/3. When we divide variables, we subtract the exponents. 8 minus 4 becomes x to the 4th. And then we have y to the 1 divided by y to the 9th. 1 minus 9 is negative 8. So in this case, I am going to write this one more time. 5, think of this as a fraction. 5 is on top. X to the 4th, that's a positive exponent, the 4, stays like it is. X to the 4th, that's on top. Now y to the negative 8th, though, is going to have to go down where the 3 is. When you have a negative exponent, at the end, we're going to move it. We move it down. If it's in the top, we move it down. And there's your answer. Okay, number 20. Before we divide, let's take care of the multiplication at the top. So we have negative 32x squared y times. You have this thing raised to the 3rd power, so that is going to distribute to all your exponents. 1/2 to the 3rd. 1/2 to the 3rd. X to the 9th, 3 times 3. Y to the 15th. All divided by 4x to the 11th, y to the 16th. Okay, I'm starting to run out of a little bit of space here, but let me see if I can put this in. 1/2 to the 3rd power is 1/8. It's 1 over 8. So I'm going to take that, okay, that's 1/8, I can put it on the side, times negative 32, which is going to be negative 4. So we get negative 4. Now let's see, x to the 2nd times x to the 9th, add the exponents, x to the 11th. Y to the 1 times y to the 15th, add that up, that's y to the 16th, divided by 4, x to the 11th, y to the 16th. Okay, now the last step here, let's go ahead and finish the division. Now what happens here, you gotta be careful. Negative 4 divided by 4 is negative 1. X to the 11th divided by x to the 11th, if I subtract that, I get x to the 0. Now x to the 11th divided by itself, that's a number divided by itself. That has to be 1. So here's the other reason why anything to the 0 is 1. If I divide this, this is like 5 divided by 5 is 1. 22 divided by 22 is 1. X to the 11th divided by x to the 11th is 1. So this is just going to be 1. So that the negative 4 divided by 4 was negative 1. This is 1. Y to the 16th divided by y to the 16th. If I subtract it, I get y to the 0, which again is 1. So what happens here is I just get a bunch of 1s. So in this case, negative 1 times 1 times 1, my answer is negative 1. That's it. Everything simplified there. That was nice. All right, and then the last one here, 21. When you have a fraction raised to an outside exponent, the rule stays the same. Every exponent inside gets multiplied by negative 4 in this case. So 4 to the negative 4, x to the negative 12, y to the negative 48. Now we're not going to leave it like that. We're going to, on top, y to the negative 48 comes on top. It becomes y to the positive 48. 4 to the negative 4 is going to go down. That's 4 to the 4th, x to the 12th. And the last thing we'll do here, we'll say, okay, y to the 48th, 4 raised to the 4th. 4 times 4 times 4 times 4 is 256. So that's 256. And let's see, x to the 12th. And that's a good answer. That's all we can do. And that is the end of your notes.